Hey everybody, we're going to do in this video some calculations based on energy and frequency and wavelength of light, okay? So these are pretty simple calculations, but you just got to practice these like all problems, and I think you'll be pretty good. So the first problem here says a green laser pointer has a wavelength of 532 nanometers. By the way, green laser pointers are so bright and so efficient because your eye is most sensitive to green light compared to other colors. So anyway, it's asking what is the frequency of this 532 nanometer of light, right? Okay, so how are we going to do that? Let's go to the whiteboard here. And so we're going to use the formula lambda times frequency, lambda nu equals c, that's given to us, right? And so what do we want? We want frequency, which is nu. So that's going to be equal to c divided by lambda. That's going to be equal to c is 3.00 speed of light times 10 to the 8th meters per second. We're going to divide that by lambda. Lambda now is going to have to be in meters, right? So first, we're going to have to take 532 nanometers and convert that. So for every 10 to the 9th nanometers, right? There's a billion nanometers in a meter. That's going to get you how many meters you have. That's going to be 5.32 times 10 to the -7th meters. Okay, nanometers on top cancels with the nanometers on bottom. Now we can plug that in for our lambda. We got to be in meters because we're in meters per second for our speed of light. So that's going to get you 10 to the -7th meters. Now meters cancels. We're left with divided by second, which is inverse second or hertz. And so that's going to get you, you type that into your calculator, 5.64 times 10 to the 14th second inverse. And that would be your final answer. Okay, so that's that one. Let's now go back and look at the next one. Next one, a photon of light has a frequency given to us, 6 times 10 to the 17th hertz, or inverse seconds. What is this wavelength? Okay, so it's going to be the same type of problem. Let's go back here. So again, it's lambda nu equals c. And this time we want wavelength. We're solving for wavelength. So lambda equals c divided by nu. C again is 3.00 times 10 to the 8th meters per second. We're going to take that all and divide by the frequency, which was given to us, 6 times 10 to the 17th inverse second. Inverse seconds is going to cancel with inverse seconds. We divide by seconds. Inverse seconds means divide by seconds. We're going to be left with meters. And our answer, it doesn't tell us what units we need the answer in. So just punching it into the calculator, you'll get 5 times 10 to the -10th meters. And that's your final answer. So these types of problems you can see are just dividing by type of problems. Check your units and you'll make sure you're good. Okay. Let's go back and try some other problems. So let's see. What is the change in energy, delta energy in joules? So it wants to answer in joules. If your water boils over and emits light with a wavelength of 590 nanometers. Okay, so it basically wants to know what is the energy of 590 nanometer light. Okay, and so we can do that. Let's go back here. And so what are we going to do? Well, we have our equations, E equals h nu, right? And then we also know that lambda nu equals c. So if we solve for lambda, C divided by, solve for nu, sorry, nu equals C divided by lambda, right? And then we can plug that in for nu up above. So we're gonna get HC over lambda, okay? And so, because we want energy, so it's good that we're in energy here. And we know H is always given to us, C is always given to us, that's speed of light, and Planck's constant. And so we're given lambda in the problem. And I know that we're gonna have to be in meters here again. We're given 590 nanometers for units to cancel. So again, we're gonna have to divide just like we did before by 10 to the 9th. And that's gonna be equal to 5.90 times 10 to the minus 7th meters. And now we're just ready to plug all of this stuff in. So Planck's constant is 6.626 minus 34 joule seconds. Speed of light is 3.008, but 3. I'm not worrying about significant figures right now. Meters per second. All of that is going to be divided by our wavelength in meters, because we have to have our units to cancel. 5.90 times 10 to the 7th meters. So meters on top, meters on bottoms, that cancels. Seconds divided by seconds, those are going to cancel. We're going to end up in joules, which is what the problem's asking us for. And if you plug that into your calculator, you're going to get 3.4 times 10 to the minus 19th joules. And that's going to be your final answer. All right, so those are some problems. Practice those problems. Those type of problems will definitely be on the exam. Hopefully they're fairly straightforward for you. Let me know if you're having any problems with those.